Did you know there's a giant mysterious dent in Earth's magnetic field? For years, NASA has been closely monitoring a strange and growing anomaly stretching between South America and Southwest Africa. They call it the South Atlantic Anomaly, or SAA for short. And it's a vast region where our planet's magnetic shield is significantly weaker than normal. Think of it like a pothole in space. This isn't just a scientific curiosity. It's a real concern, especially for the hundreds of satellites orbiting our planet. So, what exactly is this anomaly? Imagine Earth wrapped in a protective magnetic bubble. This field, generated by the churning ocean of molten iron deep within our planet's core, shields us from harmful charged particles constantly streaming from the sun. But this shield isn't perfectly uniform. The South Atlantic Anomaly is a massive area where this protection is worryingly thin. While it doesn't directly affect us on the ground, anything passing through it in low Earth orbit, like the International Space Station, is left more exposed. Why is this a problem? When a satellite flies through the SAA, it's bombarded with high-energy protons from the sun. This radiation can wreak havoc on sensitive electronics. It can cause short circuits, data loss, and glitches. In a worst-case scenario, it could permanently damage key components, turning a multi-million-dollar satellite into space junk. To avoid this, satellite operators often have to shut down non-essential systems before their spacecraft enters the anomaly zone. It's a bit like holding your breath while swimming through a dangerous patch of water. This anomaly isn't just sitting still, it's evolving. Since 2014, it has expanded by an area roughly half the size of continental Europe. And as it grows, its magnetic intensity continues to weaken. NASA and other space agencies like the European Space Agency are using constellations of satellites, like the Swarm mission, to map these changes in incredible detail. What they're finding is fascinating and a little unsettling. The anomaly isn't just expanding. It seems to be in the process of splitting into two distinct lobes, or centers of weakness. One is forming over the Atlantic, and another is developing further inland over South America. Researchers are working hard to understand what's causing this. The leading theory points to a massive dense blob of rock deep in the Earth's mantle, about 2,900 kilometers below the African continent. This structure, known as the African Large Low Shear Velocity Province, is thought to be disturbing the flow of molten iron in the outer core beneath it. This disruption interferes with the generation of the magnetic field, creating the weakened region we observe on the surface. It's like a giant, hidden obstacle deep within our planet is causing a ripple effect that extends all the way into space. One of the big questions scientists have is, what does this mean for the future? Some have worried that the growing SAA could be a sign that Earth's entire magnetic field is about to flip, where the magnetic north and south poles switch places. This is a natural process that has happened many times in our planet's history, but it could have major consequences for our technology-dependent civilization. However, the latest research offers some reassurance. By studying ancient rocks, scientists have found evidence that a similar anomaly existed in this same region as far back as 11 million years ago. This suggests the SAA might be a recurring, long-term feature of Earth's magnetic field, rather than a precursor to an imminent global flip. It seems to come and go over geological time, but the anomaly's effects are being felt right now. A recent study found that the SAA even influences the beautiful auroras we see. Because the magnetic field is weaker there, it allows solar particles to penetrate deeper into the atmosphere, which can affect the chemistry and glow of the upper atmosphere in ways we're just beginning to understand. It's a reminder of how interconnected all of Earth's systems are, from the molten core to the edge of space. The changes are also getting more complex. Data from the ESA's swarm satellites shows that the anomaly is changing differently near Africa compared to how it's behaving near South America. There is something unique happening in this region that is causing the field to weaken in a particularly intense way. As geophysicist Chris Finley noted, it's not a simple, uniform decay. This complexity makes predicting its future behavior a huge challenge. That's why continuous observation is so crucial. NASA and the ESA are committed to tracking the SAA's every move. As NASA geophysicist Terry Sabaka explained, because the SAA is slowly changing its shape and intensity, we need continued missions to keep an eye on it. This constant stream of data is what allows scientists to build better models and, hopefully, make more accurate predictions about how it will evolve. Every new piece of data helps solve another part of this massive puzzle. So, while there's no need for us on the surface to panic, the South Atlantic Anomaly is a powerful reminder that our planet is a dynamic and ever-changing system. It's a cosmic dent that poses a real threat to our vital infrastructure in space, and a fascinating scientific mystery that connects the deepest parts of our world with the forces of the sun. As our reliance on satellites for communication, navigation, and science grows, understanding and predicting the behavior of this pothole in space becomes more important than ever. The work of these scientists isn't just about protecting satellites. It's about fundamentally understanding the engine that drives our planet and protects all life on it. It's a huge, complex phenomenon, and while we still have many questions, every day we're getting a clearer picture. It's a testament to human curiosity and our drive to explore the mysteries of our own world. Thanks for watching. If you found this journey into Earth's magnetic field fascinating, don't forget to like this video and subscribe to our channel for more deep dives into the wonders of science. See you next time.